how to solve 1 raised to the power of x positive 100 raised to the power of x is equal to 10,000 raised to the power of x. So what we would be doing is, foremost, this is the question. We start off by utilizing the word consider 1 raised to the power of x positive 100 raised to the power of x is equal to 10,000 raised to the power of x. So now what I wish to do is I would be dividing both sides by 1 raised to the power of x. So this is going to be 1 raised to the power of x. This is 1 raised to the power of x. This is 1 raised to the power of x. Now clearly 1 raised to the power of x and 1 raised to the power of x will be cancelled, giving me 1 positive. Now suppose you have something like this: a raised to the power of m divided by b raised to the power of m. We can rewrite this as a over b, the whole raised to the power of m. So by this property I can rewrite this as 100 divided by 1 raised to the power of x. This is equal to, by the same property, 10,000 divided by 1 raised to the power of x. Now 100 divided by 1 is going to be 100. So this is going to be 1 positive 100 raised to the power of x is equal to 10,000 raised to the power of x. Now what is 10,000? Can I write 10,000 as 100 squared? Is it possible for me to write? Of course it is possible. So this is going to be rewritten as 1 positive 100 raised to the power of x is equal to 100 squared raised to the power of x. Now there is a formula: a raised to the power of m whole raised to the power of n can be rewritten as a raised to the power of n the whole raised to the power of m. You can flip the exponents. So this is going to be 1 positive 100 raised to the power of x is equal to 100 raised to the power of x the whole raised to the power of 2. Now what I wish to do is I would like to let 100 raised to the power of x be equal to some t. So this is going to be 1 positive t is equal to 100 raised to the power of x is t. There is a 2 there, so this is going to be t squared. Now move these two to the right hand side. So this would be t squared negative t negative 1 is equal to 0. Now utilize quadratic. So this is going to be t is equal to negative of negative 1 plus or minus root of negative 1 squared negative 4 times 1 times negative 1 divided by 2. Right? So this can be rewritten as t is equal to 1 plus or minus root of negative 1 squared would give me positive 1. Negative times negative is positive, so you get 4 divided by 2. So if I were to calculate t has got 2 values. T is equal to 1 positive root of 1 positive 4 is 5 divided by 2, or t is equal to 1 negative root of 5 divided by 2. Now this value is a very important value. This is called as the golden ratio. Now let me write that down. Golden ratio. Now there are many names given for this. This is also called as golden section. This is also called as golden mean. This is also called as golden number. This is also called as divine proportion. It's also called as divine section, and it is also called as golden proportion. So there are many names given to this, and this is one of the powerful numbers that you can come across. Now if you are interested in knowing out the value of this, so in this case if I were to obtain the value of this, then it would be approximately 1.61803398874989484420 and so on it goes. So that is the value of this golden ratio, and it has got several applications, and it is also called as an irrational number. This falls into a category of irrational number and one of the most powerful numbers in number theory. So having given you that side note, now we can utilize the representation for t. T is 100 raised to the power of x. So what I wish to do is I would like to utilize this value. I cannot utilize this value. Now since t is equal to 100 raised to the power of x, if I were to take this as 2, therefore 2 can be rewritten as 100 raised to the power of x is equal to 1 positive root of 5 divided by 2. Right. Now I take log both sides, log to the base 10 both sides. So this would give me log 100 raised to the power of x is equal to log of 1 positive root 5 over 2 to the base 10. And you know from logarithms, if you have log a power b, you can write it as b times log a. So this is going to be x times log 100 to the base 10. Now I can rewrite log 100 as log 10 raised to the power of 2 to the base 10. I can again bring this 2 over here. This is going to be 2 times x log 10 to the base 10. But from logarithms we know that log a to the base a is equal to 1. So this is going to be 2x. And 2x is equal to log of 1 positive root 5 over 2. So this is to the base 10. Right. Now 2x is equal to log of 1 positive root 5 over 2. Again you can utilize the logarithmic values available through logarithmic tables, or you can use a calculator in extracting it. So therefore x is going to be, I'm just going to write the log value. So it's going to be log of 1 positive root 5 over 2. So as I mentioned to you, you got to get the value, and after you have got the value, you have to divide by 2.